All right, so we're looking at this review for tomorrow's summative. The first two sections on the review are actually the old sections that are being retaken. They're not first on the quiz tomorrow. But this first one, 1.1, is about evaluating a function, finding the rate of change, and stating if something is a function. So this didn't go well for some of you last time, so this is your time to fix that. How do you find f of 4? Yeah, it means when x is 4, what is y? And this is really hard to read. I think it's like down here somewhere. Anybody counting down there for me? -6 sounds good, Ethan. And then f of -1 would mean when x is -1 over here, what is y? And I think it's about -1. What does this mean when you see f of 0? This still means when x equals 0. So it's looking for the y-intercept, and this one is basically going through 0, 0, right? Hey guys, if you don't want to review, you can go to ISS. That would be fine. All right, the second section of that standard is on finding the average rate of change, which, remember, does not mean to average anything. It means find the ordered pair where you put 4 in and see what you get out, and then you put in 2 and see what you get out, and then you find the slope between those. So if I put a 4 in up here, I squared, I get 16. -48 plus 1 would be -47, I think. Put a 2 in, you square it first, you get 4 times -3 would be -12, plus 1 would be -11. And then the slope would be some nice disgusting thing like that. Change in y over change in x. I'm getting -36, that says plus 11. Over 2, so -18. Did anyone else get that? Okay. Do we need to practice more on that, or are we good? One reminder is enough for everybody. I have lots of extra practice on here, so if somebody wants to see another example of something, just let me know. How do you know if something is a function or not? Yeah, pass the vertical line test would be fine. You could, graph this on your calculator. It would look like that. How would you write a list of ordered pairs that is not a function? 3, 5, 3, 6, 2, -8. There's 3 ordered pairs that fail because the x's repeat with different y's. Everybody good? That would be a fail. Any questions about that standard? Oh, I think there's one more section. Just kidding. There's also evaluate, where you put in something like this. I honestly think it's more like this time. So you would put in -3, -6n squared plus 1. You square what's inside there first. And then I think it's -108. Somebody check me on that. Does anybody need me to do the A-4 one? I don't think it's like that on the quiz anyway, but you would have to FOIL it all out first, which is a minus 4 times a minus 4. That's where I got this. And then you'd have to distribute the negative 3. And then there'd be the plus 1 on the back still. I don't know. That's what I got, but I don't think it's like that on the quiz. I think it's one where you put in a something more like negative 6n. Questions? All right, now we move on to the second standard, which is the domain range symmetry one. Remember, domain is furthest left to right. Range is furthest down to up or bottom to top. And domain is x's and range is y's. So for this goofy looking piecewise graph over here, there is an arrow on this end. So anybody tell me what the domain is? There's not an arrow on this end, so, and you start on the left, so is that negative 4, guys? Negative 3? Okay. This graph paper is just making me googly. Negative 3 furthest to the left, and then it goes to the right because of the arrow. And then bottom to top, it is going down forever, but the furthest up is positive 4. Need to see another domain example? Okay. If we were doing increasing and decreasing on this mess, just because that's something we need more practice on, what would it be doing over here? Yes, and that decreasing piece would go from x equals negative 3 until negative 1, I think. And then all of this next piece here would be increasing from negative 1 until, what x is that, guys? 5 maybe? Right? Because it's x values. And then it's decreasing again from 5 to the right. Okay, no one's, yes, no. It's an x value of 4 there? Okay, so this should be, thank you, 4 and 4 here. Because this is 4, 4 is what you're telling me? That dot is right up there? Yes? Oh, it's 4, 3, but over there it went to 4. I got you. I'm good. I'm good. I'll be okay. Baby. All right. Do we need more domain and range practice? Anybody? Okay. How do you decide where a function is discontinuous if it is rational? Yes. Yes, the denominator cannot equal 0, so you would say it is discontinuous if x equals 6 or x equals 1. This asks where it is discontinuous, so I went ahead and said if x were 6 or 1, it would be discontinuous. It's kind of asked where, you know, it's one of those double negative things. Do you say it cannot equal, but it is asking where it doesn't work? Everybody okay? Even or odd. What makes a function odd? Because both versions of the quiz have one or the other of those questions. Lucas? Okay. And what is that called? Yes, origin symmetry. And the other one, guys? An even function has y-axis symmetry. Okay, so any of these 6 that I have up here, odd? Yeah, I think this one is. It's like it goes over 1 and up 4, or left 1 and down 4. Go over like 3, it's down 2, left 3, up 2. I think it would spin, right? So this one is odd. Are any of these up here even? This one is? I don't think it is, because it has a line of symmetry, but it's not the y-axis. I think this one is even, yes, by looks. But what about any of these down here? All neither? Everybody good with that? Anybody have a question why one is neither? Okay. Then we're on to the new stuff. Can you type this equation in real fast and find the zeros, the maxes, and the mins? And someone remind me that I froze this in just a second. Find an appropriate window too. Oh, it is. All right, how we doing? Anybody find a window they liked? What do you have, Grace? Yes. I think I only had like maybe -8 to +8 across, but it doesn't matter if it's too, if you have extra space around the edges, as long as you can see the bottom and everything. All right. Who has the zeros for me? Anybody? Go ahead, Grace. Negative. Yep. Yep, you're good. Wasn't this one -4.59? I don't know. 5.1? Okay. Thanks. And then... Okay. And we said the y-intercept, if you put in a 0, you get out a 6. Everybody knows how to find that, right? Just trace 0 or go back and put a 0 in up here. There's no y-intercept button. Okay. The max and the min. Anybody? The max is at... One more time. 0.93 and the min? $3.60 or does anybody have? Yeah. Okay, 5.9. Okay. I think on the quiz it says to the nearest hundredth. Yep. I don't care on your review, but on the quiz it does say to the nearest hundredth. That's 2 decimal places accurately, guys. And then what was it? -30 something? 35 point. Anybody got something? Anybody else? 2.8? 1.8? All right. Anyway. And then we get to the tricky stuff. Find the increasing and decreasing. That's the one that uses the maxes and mins. I would suggest, and you do have to draw a sketch, guys. When it says draw a sketch and state your window, your sketch can be really rough, okay? Doesn't have to be accurate at all, just so it's making the right shape and everything. I would label the X's up here. And this point had an X value of 0.93. So increasing or decreasing first? Coming from the left, it's going down. It is going down in Y values as long as X is coming from the negative infinity until what X value? Okay. Is it decreasing anywhere else? Again, from the max, which had an X value of 0.93, to the right, it will keep going down. As we go to the right, the Y value will keep going down. The function value, the Y, is going down as long as X is, and you have to state the X intervals. All right, and the increasing is then from negative 3.59 to 0.93, the place where it's going up. Everybody okay? Now, the inflection point is totally an estimate. So anything you want to pick in here will work for me. If we actually found these X's, they round to about -4 and +1. So you could average those two numbers. What do you want to do, guys? -1.5-ish? What did you pick? Or -1? Okay. So you traced along. Oh, you averaged them. Fancy. Okay, -1.34. And what would the Y be then if you typed in -1.34? You have to actually type that into the graph. Does anybody have it pulled up still? Go trace -1.34. One more time. Okay, that's supposed to say -12.17, I think he said. All right, anyway, it should be somewhere in here. And you don't have to be that. You could have just used whatever -1 is or whatever -2 is, but you have to trace along in here. What they did was they took these X's on the max and the min and they actually averaged them, okay? You don't average the Y's though. How do you find the Y value that goes with that X? Yeah, you trace it along on the graph. Go trace and then decide what you want to put in. Now, whatever you pick for your inflection point, you have to use that same X value to describe the concavity. So if you want to say to the left of this, what is this graph doing over here on the left? Yeah, that's a happy face, right? So it is concave up from the left until you get to -1.34. And again, whatever you picked for your inflection point is what the X value should be there. If you didn't pick that number, that's fine. And then last would be concave down, which would be all the places where to the right of this, yes? So from whatever X value you have on your inflection point and to the right. So you can just, when you have this pulled up on your calculator, if you want to just trace along here and go, somewhere in there looks good, and write down whatever that crummy number is. Or you could say, okay, I think it's close to -1, so I'm going to actually type that in so I have a nicer number to work with. Okay, so you could use -1, -7. You could have used -2, -22. Last hour we used -1.5 and -14.625. The X is the only one you have to write down more than once anyway, right? Anything along here would work. Any questions about graph analysis? Is there one of those ideas that is a struggle for you? Is it the inflection point? Or the concavity? Or none of the above? Amello? Okay, if this had been a question on the quiz, anywhere between this min and this max, I could pick an inflection point. So maybe I could have just called this -2, -1. Now it's going to be different when you have the equation because you have to use your calculator. That would be an inflection point. And so you would say this is concave up from the left until -2. And then you'd, because this graph has another max and min over here, you would need another inflection point somewhere in here, like maybe 1.50. So it would be the same concave up on this side again from 1.5 to infinity. But in between those inflection points, it's curving down like a sad face, right? So it would be concave down from there to there. So again, it's just an estimate. All right. This is describe the transformations in the right order. The one on the quiz, the order will matter. Okay? What my suggestion is that you start inside just like you were doing order of operation. If I told you to put a 7 in here, you would add 5, then multiply it by 3, and then subtract the 1, right? So tell me the order that those are affecting it. What is the +5 doing to the parent function? Horizontal shift left 5. Okay? The second thing is that 3. What is that 3 doing? Vertical stretch by 3, factor of 3. Okay? The y values would be 3 times as tall. And then on the back is a -1, and that would be a vertical, just kidding, vertical shift down 1. And on that particular one, the order would not have affected it, but this next one does. Okay. What is the order on g of x over here? Horizontal shift right 2. Then what's the second thing have to be? Yeah, if you were to put a 7 in here again, you'd go 7 minus 2 is 5, 5 cubed is 125, but then the negative out here would make it negative. So the second thing is this negative, which is a what? Reflect over x-axis. Flips it up and down this way. And the words for the last one? Vertical shift up 7. That's the one that order matters, because if you went up 7 and then you flipped it across the x-axis, it's going to be at a totally different place than if you simply turned it upside down and then shifted it up 7. Questions? So there's one where you have to write the descriptor, and there's one where you have to physically rewrite the equation, having it do these things in this order. What would a vertical shrink of 1/2 look like? Inside or outside? Outside, so it would be 1/2 square root of x. Then it's supposed to go left 3, inside or outside? Inside, so it is the opposite of what it seems. So it's +3. Up 5, +5 on the end, okay? And then I'm supposed to reflect it over the x. Anybody know how we're going to make that? Is that inside or outside? I'm sorry, I'm hearing two different things. Over the x is on the whole function, right? And how are we going to make it be on the whole function? I don't think I put it that hard on the quiz, but the only way to reflect that over the x-axis after a vertical shift is to put the whole thing in parentheses. Okay, because the order again, here was the parent function. It was supposed to get a little bit flatter, and then shift left 3, and then reflect over the x-axis. I'm sorry, I'm so sorry. Go up 5, and then reflect over the x-axis, so it wound up way down here. I don't think you need all kinds of extra parentheses on the quiz. All right. You also on the quiz do not have to graph one like this. It's matching on the quiz. So here is your homework. You were supposed to do some of these. Here's the parent function. Who wants to pick one? Anybody tell me what 2f of x would do? Stretch it to which ways? X's or y's change? The y's change. So it's still, if I put it on this, I've enlarged these so that you can see them a little better, but if I put it on this one, it still has an x-intercept of -3 and +3. But instead of going up on the y to 3, it would go up to 6. And it's still going over to horizontally because it has not changed horizontally. All right, so I'll do one more in red. What about this 1/2 f of x? Yes, so it's the same thing. Crosses at -3, +3. It used to go up to 3 on the parent, so this one only goes up to 1.5. So this just looks like Hofbauer sat on it. It's kind of squished. All right, then we get the nastier ones. What about this one? So it goes left 3. So that would be this one that used to be at -3 is over at -6. The one that used to be at 3 is now at 0. So that's just the left 3 part, but then it's also reflected over the x. So now the intercepts stay the same, but instead of going up 3, it's going down 3. So it should have exactly the same size and shape. Those are both rigid transformations, but it's in a whole different place. So this is the final answer down here. You certainly don't have to draw both of them. On the quiz, like I said, it will be matching. What would this do? Anybody know? Horizontal. Inside is the opposite of what it seems. So it was a shrink, a smush, a compression by 1/3. Changing x's or y's? X's. So instead of going all the way over to -3, I only go over to -1. Instead of going all the way right to 3, I only go to +1. The y's don't change though. It still has to cross the y up here at 3. But instead of going over to the right 2, I go 1/3 of that. So somehow I'm supposed to have 2/3 up here. Okay, so it should look like we pinched it. Again, you don't have to do this, but you have to be able to match them. I have some really good practice on that. Matching here and here some things. but I'm going to go ahead and keep going, and then we'll come back to those if we have time, okay? What is the parent function for this one? Just square root? Everybody okay? Cube root would be going both directions, because you can take the cube root of positive and negative numbers. Everybody good? All right, what things have happened? Can you describe them in words? It was normally go like that. So it's gone left, how much? 6, is it? And up 1. And then it's obviously upside down, but I think the stretch will take care of itself when we put in an ordered pair. It does say you have to show work for the stretch. So we have a parent function. How do I do left 6? Be careful. Plus 6 inside and up 1. Yes. We're good? Inside is the opposite of what it seems? Okay. Now there's a stretch. It better turn out to be negative. Do you want to use this dot or this dot down here? Anybody care? I think that one is -2, -6 maybe. Can anybody tell me? -5? -2, -5? Okay, so if I put those values in, I'd have -5 equals a square roots of -2 plus 6 with a plus 1 on the back. What is someone going to do? They're going to try to put the plus 1 together with this square root, right? They can't. You can subtract the 1 over here right away and get -6. Inside here we get 4, and what is the square root of 4? So we have 2a equals -6. If we divide both sides by 2, we get -3, which it was going down 3 and over 1 for the very first dot. Okay, but you should be able to show the work for that. Sorry, I wrote it kind of sloppy. Can you tell what it's supposed to be, your final answer? All right, I have a request on this one. Could you change this last rule down here to if x is greater than or equal to 3, please? All right, so you have a question that's just evaluate. Please don't get that one wrong. Put in a -5 would go into which rule? Okay, -5 plus 4 is -1. Squared would become +1. -2 times 1 is -2. -2 would go into which rule? The second one, because of the or equal to line. So all that comes out of that rule is a 3. The third one is put in a 4. Okay. The 4 is greater than 3, so we put it into the last one. 4 minus 5 is -1, but the absolute value makes it 1. So I have -3 times 1 plus 9 is 6, I think. Everybody good? Evaluate carefully, use your calculator if you need to, use parentheses, whatever you need to do to get those right, because that's just plugging in numbers. Where could this one possibly be discontinuous? There are only 2 values that it could be discontinuous at. Yes, it switches rules if x is -2 and if x is 3. Does everybody see what I'm talking about? That's where it switches rules. From -2, you switch here to here. From 3, you switch here to here. Okay. We're going to move on and graph it, and then we'll talk about that discontinuous piece. All right. The first one is a parabola. Could you type this in your calculator and find a bunch of ordered pairs? Yeah. Absolutely. The vertex is at -4, 0. It's opening down, it's been stretched, it's a parabola, all that good stuff. But when can I put in a -2 to graph it? Should I put in a -2? Yes, because that's where the open circle is. If I put a -2 in here, if you don't draw the open circle in the right place, it's not going to be full credit. Okay, you have to put a -2 in. Add 4 becomes 2, squared is 4, times -2 would be -8. So down at -2, -8, there should be an open circle showing it goes right up to that. What did I do wrong? Oh, I went way too far with my, yeah, I can't read those little numbers. It was only supposed to go to -4. When it went, and then down. Sorry. Like, why is that looking so funky? Woo! Still looking pretty funky because I did a lousy job of graphing that part. All right, if you'd put in a -3, you would have got out a -2. If you put in, then there's symmetry, so it should be going this way evenly. All that good stuff. What about this second piece right here? This is your favorite, right? Yeah, and it's up at 3. I tried to do it in the wrong spot earlier today. It's up at +3. And at -2, it has a solid dot. And then over here at 3, 3 should be an open circle. Mine is not at 3, 3 very accurately, but pretend. Now, I changed this rule to greater than or equal to for a reason, because on the quiz, this is how it happens. If you put a greater than or equal to here, this one should be a solid circle starting at, now you could type it in your calculator and find some ordered pairs. What does it have, guys? -3. Do you remember where absolute value is? Math, over to the right, enter, or second 0. And then it has x -5. Outside the parenthesis, it has a +9. Okay. Then if you go to the table, it's these blue values right here. So at 4, it's at 6. At 5, it's at 9. At 6, it's back at 6. At 3, it's at 3, and it's supposed to include that. So at 3, 3, we fill this dot in. And then it goes to what, guys? I didn't count that right. 1, 2, 3. Should be there. This graph paper is ridiculous. Should we do it that with a V? All right, so the question was, where is this discontinuous? It is a multiple choice question on the quiz. Please do not pick something random. It should be where the rule changes. But did the rule change and leave it discontinuous at -2 or at +3? At -2. At +3, they met up, right? When it changed here, it had open circle at 3, 3. Here, it had to put a 3 in, and it started at 3, 3. So they met up, and they did not leave a gap. All right, write an equation. This is the last one we need to do, right? For sure. And then we can see if we have time for extra. Okay, 2 rules, not 15, thank goodness. The first rule is it stays at what y value? -4, as long as x is less than -1. Do I need it or equal to? No, because it's an open circle. Then if I go to the right, there is a diagonal line that has x values from -1 to +3. Those would both be less thans, either one needed or equal to. -1 is filled in here, and then over at 3 it's open circle. And then we need to write the equation of that line. We could write some ordered pairs, find the slope, do point slope, all kinds of fun. But most of you can eyeball it. Where did it cross the y-axis at? And what is the slope? Be very careful. Yes, it's going down 1 and over 1, right? So it's -1 slope. If you just put x minus 3, that would be going up 1 into the right one. All right, I'm going to flip back to a couple of these. Can anybody tell me which of these 4 graphs down here, the parent one is up here, okay? That's the parent function. Which of these 4 down here would be a 2 inside? What does a 2 inside do? Changes x's. It is a horizontal shrink. It is pinched. It is not changing the y values, it's changing the x. A horizontal stretch of 1/2 x inside would stretch the x values. This one is B. This is a vertical change, and this is a vertical shrink. The other thing that can be tricky is reflecting. This one is reflected across the x, so that would be this one. This one is reflected up and down. Yes, absolutely.
This kind of stuff is very confusing.
Yep, absolutely. Thanks, you too. There's some good practice in the remediation bin, so we might just grab one of those if it's in there. I'll make sure it's in there by then.